Hello, everyone. Welcome back to the course A. And in this week's Astro Professor video, Professor Dollyfoot is willing to answer your three questions. And now I'm going to summarize the three questions, then Rolf will answer them one by one. The first question is about the experience of the maintenance. Because the students ask, we have the weld of the rails. Maybe the maintenance for the welds and the rails are a bit different. Could you please explain a bit that?
Yep. Thank you. First of all, I'd like to thank all the students to give their feedback and also to upload their questions and also share the questions they have in the daily life or in their own country. I really appreciate this. One of the questions about this one is about, of course, design. You also can think about the maintenance, but that will come back in later on when we talk about LCC and maintenance in course C. No problem, but we can explain it. So what is the real difference, or is there a difference in maintenance for just regular rail or with welds? And I think, yes, there is. It's depending which weld. When you have a welded weld, so that makes that the hardness is different and is different. That means you can say, okay, I do grinding, for example, to make a nice shape because of the geometry. Then mostly you do grinding. For example, in Holland, we do every 50 megatons in curves and 40 megatons we go in the straight track. That's more or less based on refurbishment of the geometry. But the problem is the hardness of the rail is different than the hardness of the weld. That means that when you do nothing, then the weld is more harder than the rail. That means you get more wear on the rail, and the weld will be like a small bubble because that's not wearing away. So you need to do something. So when you don't grind at all, as a preventive or cyclic grinding, then you have to do maintenance on your welds. Otherwise, you have a small bump with the train after 10 years, and that's okay, but then you get problems with the construction of the sleepers or the ballast, and you get transition zones, and that's what you don't like. So that's one. But you also have isolated joints, and that's also a weld, you could say. It's not a welded by material, but that is a construction weld because of the isolation of the rail bars, because of the electric part. And then you have other things, because in between you have no rail, that's just plastic. And then you really get this hammering effect on the construction, and therefore you have a transition zones. The ballast will be broken within a few years. You have to do a lot more maintenance on that spot, and that's not only the iron, that's also all the rest: the fist plates, the bolts, the sleepers, and the ballast. So that's a big one when you talk about maintenance to do.
Thanks, Rolf. Then we go to our next question. That is about the specification or the identification of the real type numbers, because some of the numbers may refer to the weight or the shape. Could you please elaborate or maybe give some example of that?
Yeah. That's good. There's no problem. I think it's very clear. Is there a systematic thing? Yes, there is. When you look at the normatives, you see in the European normatives or the UIC, whatever, ISO, not a big deal. But then the first two numbers of the name of the rail is always the weight per meter. So when we talk about in Holland, for example, we have 54 E1. That means 54 means 54 kilos per meter. You also have on the freight line, we have 60 E1, that means, or 60 E2, that means 60 kilogram per meter rail. So that gives an indication of the weight. And when you like to know what is the shape, then you have this E1, European standard number 1. That's just appendix 1, you could say. That's the basics. 54 E1 is the basics. But when you have 54 E5, that means there is appendix 5. And that's something telling about, okay, how does this shape looks like. And then you can see, okay, so the first two numbers are the weight, how much steel is there per meter. And the second part of this name is this about the shape. And that can be basics like E1, that's the basics, the regular shape geometry. And when you talk about E5, for example, then you have talking about an anti-headsack profile. So a different, slightly different shape of the head of the corner when the running band meets the flange, and that area is a little less And that's why we give it a different name, because it is different shape. So hopefully this is clear enough to understand why and how the process looks like to nominate and to name the rails. But you're right, there is really a process around this. Yes.
Okay, great. Then our last question is about the inspection and maintenance of the rail wear. And the students ask, is there any preventive or the repair technologies or innovative ways that you would recommend for the quality control, for this real quality control? Yeah.
Yeah, I think it's a good question, because it's also about politics. And what do you like? Do you like to wait till the end of the assets so it will pass away? It's broken, or is not functioning anymore? Then you are more or less doing it the old way. Wait till it is broken, go inside the track, replace it, and go back, and then you have your next cycle. But that's a little old-fashioned. You like it, that's nice, but then you have a lot of people needed, and you're always on the edge of your safety, because waiting 1 week means it's broken, no trains or derailment. You don't like safety first. So I think the better is to say, no, I like to be preventive and check the quality, maybe per week or daily, that's even better, out of a running train. And then the question is, okay, is that the best way? I think yes, because then you can make dedicated maintenance schemes ahead, and knowing what to do, where, on which corridor. Then you can make a nice planning, drinking coffee, relax, no panic. I think that would be the way. And you only do maintenance on the spot where it is needed. So you're also saving money. The other thing is you have to do more monitoring. You have to do other measurements tools than just for safety. For safety, you only need geometry, and you have to control the cracks in the steel by non-destructive research sensors or whatever. And that's what is done in the old days and still everywhere in the world. To control safety, you do these two things. When you like to do preventive, you need different tools. You need axle box acceleration sensors. You need laser Doppler vibrometry sensors to see the dynamic stiffness, because you like to see what is the status of the full system. And then you can see a lot more, but that's not common. And that will be common, but we use it already for more than 10 years. It works fine. But people are not get used to it. I think that would be a nice storyline to tell to others as well, that it is possible. You can use these techniques, but it is not common. So it will take some longer time that it will be common, and that we don't do the fire brigade anymore, but just to prevent and make the right choices on the right spot in the right time. So let's wait for that.
Thanks, Rolf. Since this is the last video for this course, do you have some final comments to our students?
Yeah, I think this was the first run about design track and train. So that's good. Now we make the operations, and then we do for maintenance, life cycle, and then we have the capstone. So I think hopefully you enjoy this. You learned a lot, and you like to go on to get the full system approach, and then you're really an expert at the end. So please enroll yourself for the next course about operations. Then you learn about how to the time schedules, how it works with the trains and safety over there as well. And I think then you can make the next step, and then at the end you are really there to understand the full system of railways. So when you like to be an expert, please enroll yourself and go on. So we see each other next time. Thanks.
Just now, in Professor Donald's answer, he addressed this new technology LDV, that is a laser Doppler vibrometer. That is a newly developed method to detect the track detections and to monitoring the track conditions. And this is fully developed by our TU Delta team. And with this technology, last week we participated a demonstration in the DG Track event, which is held in Amersfoort, the Netherlands. And in the following video, I will show you how this device looks like and what kind of applications can be used.
Great. Yeah. Now, good luck with that.
Yeah. Thanks. Hello everyone, welcome back to the course. The course team today is visiting one of the important events in the Dutch railway that is called the DG Track. that is about the demonstration of the digitalization methods for the railway track applications. And we, as a TU Delft team, we also have one demonstration, and I would like to show with you. Here, this is our newly developed solution using the laser Doppler vibrometer to detect the vibration signals on the structure. Here we have one LDV device, and this has a laser targeted on the structure surface, and when there's any vibration of the surface, then it can be detected from the signal here. I can show you, for instance, now I just hit this rail piece a bit, then we see some oscillation signals, and if I hammer the rail, and we can also see a different signal with different frequencies. When analyzing the frequency components and amplitudes, then we can detect the structural properties and also to diagnose the degradation of the structures. For instance, in this structure, when the train is moving, and then we can see the vibration of the bridge, the track, the train, and also the embankment, the different components based on this laser Doppler vibrometer signals. And I will also show you now the signal is almost flat, but if we make the train to move, then we see some oscillation of the bridge, and when the train passes, there's a huge oscillation. And if there's any detection of the structure, it can be effectively diagnosed by the train. And so we have already implemented this laser Doppler vibrometer to our CTO management tree, and put it on board and targeting on the railway track, and it can detect a different type of defects of the track infrastructure. This is a timeline of the innovation of this technology. We started the concept from about 2010, and now we already got this prototype. And this is a new European project. I'm for real, and we will also apply this new method to achieve the goal of this project. And there are also some other demonstrations regarding the digitalization solutions provided by, for instance, Microsoft here and as well, and also ProRail and NS at those sites. Thank you.